The concept of postnormal science was developed by the philosophers of science Silvio Functowitz and Jerome Rawitz in the 1990s to offer a new approach for the use of science for policy on issues where facts are uncertain, values are in dispute, stakes are high, and decisions urgent. But why did we need a new approach to science policy? What was wrong with the normal way of doing science? Hello friends, welcome to our series on rethinking science for a complex world, and in this video we are going to talk about the concept of postnormal science. Have you ever wondered why is it that despite the fact that science has made so much progress in the last century, we still haven't come close to solving any of our global challenges? Take for example the issue of climate change. Climate science over the last few decades has generated enough consensus around the fact that there has been a significant increase in the Earth's surface temperature since the Industrial Revolution, that this increase in temperature is mostly caused by anthropogenic or human-induced factors, and that climate change is responsible for large-scale global environmental changes like sea level rise, melting of polar ice caps, increasing forest fire outbreaks, declining agricultural productivity, and increased instances of extreme weather events. So, despite this progress in the science of climate change, why have we not been able to take action to solve the problem? Well, this is partly because problems like climate change fall into the category of something called wicked problems, which means that there are multiple uncertainties in the system and there are multiple stakeholders involved with very different priorities and preferences, making these problems much more complex and difficult to address. Let's take a closer look at the problem of climate change. We know that greenhouse gas emissions in the form of air pollution is one of the major causes of climate change. But since polluted air can spread over a global scale, it can be very difficult for a country to determine the local causes of air pollution within their geographical area and take meaningful action to reduce air pollution. An example here is the case of air pollution in the city of Delhi, which is the national capital of India. Every winter, Delhi gets covered with a thick layer of smog, and the reason for this polluted air could be anything from vehicular emissions from cars on the city's roads, or the burning of stubble in the agricultural farms across northern India, or the burning of firecrackers during the Indian festival of Diwali, or a contribution of all these factors, or something else. Now, it is very difficult to determine the scientifically accurate sources of air pollution and the extent to which they are contributing because of the nature of the problem. So, if we were to take action to reduce air pollution in Delhi by either cutting down vehicular emissions, stopping stubble burning, or banning firecrackers during Diwali, then we also need to understand that there are very different groups of stakeholders involved in each set of actions. And because of the scientific uncertainties, it is very easy for each stakeholder to put the blame on the other group and evade responsibility for taking action. This example shows that science alone does not have all answers, and that we cannot resolve all uncertainties around a wicked problem like climate change by depending only on science. This means that we need to rethink our traditional linear approach to science policy. Our traditional understanding of science policy has been that science should inform policy for our society, or the fact that doing more science, that is collecting more data and making policy recommendations based on scientific evidence alone, would automatically lead to better outcomes for the society. But this model of science policy does not work in the case of wicked problems. And in order to address wicked societal problems, we might need another approach where scientific institutions work closely with the society to together design policy. Let's look at another example. Building roads in the Himalayas is always a cause of concern because of the fragile geology of these mountain ranges, which becomes more unstable due to dynamite blasting involved in the construction of roads, making the Himalayas prone to landslides and flash floods. In the last decade itself, Uttarakhand, a state in the Indian Himalayas, has faced two major landslide disasters, killing thousands of people. Besides, the construction debris in the form of rocks and gravel falls into the mountain rivers and forests, putting the Himalayan biodiversity at risk. But if we look from a development perspective, construction of roads is required in the region as many Himalayan villages have no connectivity to the cities, making it difficult for the people to access health and education facilities or employment opportunities. So, we have a situation where there are very different but legitimate concerns surrounding an issue, and the stakes are very high as we don't want people dying because of the landslides and related disasters in the Himalayas. And all this is taking place in the Himalayan ecosystem, which plays an important role in maintaining the global climate. This is another example where science alone cannot provide all the answers. What is required instead is a process of active negotiation among all legitimate stakeholders. Which is not an easy thing to do, as every stakeholder group has very different priorities, possibly different ethical and political commitments, which can result in a conflict of values, and science alone cannot resolve these differences. This is why philosophers of science Silvio Functowitz and Jerome Ravitz came up with the concept of postnormal science for thinking through different strategies for engagement between science and society depending on the type of problem at hand. They propose 3 ways of approaching science depending on the intensity of uncertainties in the system and the intensity of differences in values or the stakes involved in the decision. First is the zone of applied science, when system uncertainties are low or uncertainties exist only at a technical level, and decision stakes are low because either there are no external interests involved in the research or the multiple parties involved in the decision do not have widely different interests and values. In this case, scientists can proceed with the normal way of doing science within our laboratories, which Functowitz and Ravitz called applied science. Second is the zone of professional consultancy, when system uncertainties exist because we are dealing with a new and unexpected situation, but decision stakes are not very high because we are working with only 1 or 2 clients at a time. But they are higher than in the case of applied science, as the decisions may still have a broader impact on the society. And finally, we have the zone of postnormal science, where system uncertainties are very high, which cannot be resolved with standard mathematical or computational techniques, and the decision stakes are also very high as they reflect the conflicting values and interests among stakeholders. This is where the scientific process needs to be made more democratic by fostering participation and dialogue across diverse stakeholder groups who are directly affected by the problem at hand.